How's it going, everyone? Julier Gonzalez here. Now, we're going to explore now the section of the component styling to understand now how do we get here, especially with React Native, and briefly go over to understand is the fundamentals. So everything going forward is based on this. So React at the end of the day, the TLDR, this is UI framework that allows you to build these specific elements on the UI, right? So you can compose that but on the web. However, because now on Facebook, aka Meta, they want to merge that into one single development, the web and the mobile. So they come up with this framework that behind the scenes it uses a single thread, or in other words, it uses the main thread, which is what is React is going to do, which is now committing change and do the rendering mechanism. When you have now the triggering phase, the rendering, and the commit. So this phases of the React mechanism to render UI components. So first on the triggering is detecting when this rendering happened. If this happened at the root elements, that is going to now re-render all of the elements. However, and then commit those changes to the DOM, which is using behind the scenes they create elements, and because if this is the first render, it's going to now call is the append child. It's going to create the entire element on the initial load if this is the first time that the app is mounted, or if this application, for example, the state update happens at some point in the render tree at some level, it will now detect when that change happened, what is the component that triggered that state. So React is now keep tracking of that, and then render the components, aka evaluating that component, and if that component contains more React component, it will render that, aka will call them until there is no more component into that. So this is part of the stuff of rendering that a lot of the time when you're writing these React applications, you want to avoid or to want to minimize as much as possible. So once that is done, right, then now the commit phase, which is going to only apply the necessary DOM updates based on this new version of the virtual DOM, and then replace that with the DOM in there. So the idea of this is with this mechanism of a virtual DOM, which is something that I would like to recap about the mechanism. React.dev. Yep. So for example, like this, describing here the adding interactivity, describing the UI. No, is the adding interactivity here. The different phases here, the trigger, the render, and the commit, right? So on the commit, if you go take a look at this, React commit change to the DOM. For the initial render, so React will use the append childs to put all of the DOM node created on top of the screen. And it do that because at the end of the day, React is a JavaScript library that now use the DOM API to create all of these UI elements, right? To create for single or a huge amount of UI elements, right? However, if this is re-rendered, React will apply the minimal necessary operations calculated while in rendering to make the DOM match the latest rendering outputs. So React only changes the DOM if there is a difference between rendering. You might wonder, how does React actually take a look at this different React, at this difference, right? So yeah, it's pretty much like that. It's like how now React um, so now how React, right, is looking at this difference between renders. So if we take a look now at the virtual DOM, all right, on React, okay, the virtual DOM and internals, right? So the virtual DOM in VDOM is just a concept around the idea of a virtual representation of the UI that is kept in memory and sync with the DOM, sync with the real DOM. So by a library such as React DOM. So this reconciliation process, which is something that React DOM, the library, actually does behind the scenes, is say, hey, let me now have this representation of the DOM as a tree, data structure, and then only update those or sync with the real DOM, sync with the real DOM, and then sync with the real DOM. So in other words, is some of this, so this synchronization here, so since the virtual DOM is more a pattern than a specific technology, people sometimes say they mean different things. In React world, the term virtual DOM is usually associated with React elements, since they are objects representing the user interface. React, however, also uses internal object called fibers to hold additional information about the component tree. So this virtual DOM, that a lot of people think that this is React elements, but also has some sort of internal data called fibers that represent additional information about the component tree. This ideal representation kept in memory in sync with the real DOM. So if the virtual DOM for some reason change, it will only apply those changes to the DOM. So for example, if an attribute, which is something that they mention here, so Shadow DOM and the virtual DOMs are two different technologies, or they're two different things. Shadow DOM is a browser technology designed for scoping variables in CSS. And the virtual DOM is a technique to hold the ideal representation of the UI. I know I'm repeating myself, but to hold the ideal representation of the UI kept in memory and sync with the real DOM. So there can be quite a lot of questions here, right? So what is React Fiber? So we perhaps would like to know more about this reconciliation mechanism, that it holds that reference into memory and then match and then sync with the real DOM. So for example, this approach enables the declarative API of React. You tell React what state you want the UI to be, and make sure the DOM match that state. And it makes sure the DOM, exactly, you tell what state will be using the virtual DOM to React. So the React DOM actually is holding this reference along with some additional information called fibers. This is interesting, fibers. And fibers is something that is being used for concurrency. Here we are actually connecting all of this kind of stuff. Why is that? When we talk about threads here, right? Which is a very interesting, not that kind of stuff. I mean, this is a type div, but we want this to at least threads versus processes, right? From Yep. When we explore about this, which is quite interesting, by the way, the difference between the process and the threat is that, well, just to recap a little bit, so a process is a set of instructions, is a program that contains a set of instruction that is usually that is stored in on disk, and then when it's loaded to memory, and the execution, the CPU is execute that, it becomes a process. So a couple example of processes you have now: program counters that indicates what is the next line to be executed, the stack that now take a look at the local variables and keep track is the call functions, or the return memory address, the register, which now holds and keep track is the memory allocation that you might go with, and more. I think an important feature of processes is that they have their own independent memory address. So other processes, if they misbehave, they cannot interrupt other processes. So this isolation process, or this isolation feature, is something that browsers like Chrome are well known about. That anytime you create a tab, you create now behind the scenes is a process. So what is a thread? So a thread is now this single unit of execution. To be more precise, it is made of these different program examples that I mentioned before, such as the program counter, the stack, the register, and JavaScript has a specific implementation of the JavaScript thread, which is made of the global execution, function execution, the call stack, the heap, and the event handling or the asynchronous nature of JavaScript, which is the event loop, the macro and micro tasks to defer tasks to be completed at some point in the future. And you have now the macro that has a lower priority than the micro task, which is where you resolve promises here, and on the macro timers, you know. And also is the web API that now from that thread, the JavaScript thread, it can have access to, whether it's on the web or the server. But the point of this is to, when we look at threads and we ask a question like, so how does the OS run a process or threads? So it does that by context switching, which is the process of switching off the process from the CPU and pass another process to run. So because this process involved is for the OS to store the state of that program along with the different states, doing this is something that is expensive. So because not only, so you only have is to store the state of the applications and update the kernel data structures and the memory page. So threads also can do context switching, but it's much more cheaper since they share now the same memory. So another thing that is important is a thread, when misbehave, it can bring down the entire process. So the idea of explaining this concurrency, or how now the OS is running the threads or the process, is because that process, the context switching, is so expensive that there are different mechanisms to come and solve with that. One of them is fiber, and the other is coroutines. So both of them are now focus on cooperative concurrency rather than preemptive concurrency. Where, in other words, it's like instead of actually at some point let some sort of instructions can interrupt the execution of this function or this program, with this cooperative stuff is at the application level that you need to handle these coordinations for that. Again, something that is this cooperative schedule. This cooperative schedule.
And coroutines.
So I mentioned this, and I know that I dive deep into the, almost the bare bone, but it's because a lot of this particular concept that now come from the low-level language is being used by the web as a way to solve these particular problems of the concurrency, or in other words, the problems of how you can now render multiple user interface without blocking the main threads. So, yeah, I just want to briefly describe this one.
Examples of fibers and coroutines.
Mm-hmm.
These mechanisms trace
complexity for even low context switching. Exactly. It trades complexity for even lower context switching. In other words, for threads, this lower context switching is, hey, I don't need to actually hold the state of the, I don't need to save a lot of state of the program and update the kernel data structures and the memory page and all that kind of stuff. So even for this lower context switching costs or small state that I need to update and keep track,
complexity for even lower context switching cost. In general, they are cooperatively scheduled.
Exactly. So in general, they are cooperatively scheduled.
That is, they must yield control.
They must yield control for others to run. This cooperative, okay, that's again very interesting. So in general, they must, in general, they are cooperative schedule or cooperative concurrency. Cooperative schedule, that means that one thread or one process must yield control for others to run.
For others to run. In other words, the application itself handles task schedule.
The application itself handles tasks. In other words, the application schedule handles the task itself. This is something when you are dealing with generators and promises, when you are now passing control and return it. Let's make a quick example here, briefly. I don't need to do that. Let's go to CodePen. Or that'll be something interesting at least to show you quickly. It's like, if you want to mimic the behavior of async and await, right? Using generators and iterators, which is the way of how you can now coordinate is this stuff that needs to happen at some points, right? This concurrency or this task that overlaps at a time. So in other words, that, hey, I want you to now call this data from this server, and once that is done, give it to me here. So this coordination is something that we can do right now in the language with generators and the generator iterators and promises, which is all of this abstraction that help us to deal with each one of them. So with generators, we can now easily describe as flow control. What it means is that we can define the several different steps and to solve the non-local and non-sequential problems. In other words, we can now run or execute line of code, a synchronous line of code, for example, in a sequential blocking way, which is the way of how we plan stuff. So we promise that the value proposition of this is that let's go to wrap now a value, or let's go to eliminate time as a concerning factor, so we can now have that data when that is available. And the iterator, which is now a design pattern for typically stepping through a data, pretty much like a database, as you're quite familiar with, when you are now paginating that, so you want to go to the next one, the next one, next one. But here we're going to do that for flow control, right? So let's bear with me. Bear with me, because we're gonna see what is the meaning of all of this entire narrative, which is, let's say we want us to now fetch data, simple, right? From the the type, oh my god, is the user type in placeholder API, I think it is, exactly. So it's going to fetch some data, which is from a mock service that you can actually do that. So instead of going with a promise like this, we're going to create our own flow that look like how we plan stuff in the sequential and blocking fashion. Now, so in other words, this is the URL that we're going to do. Let's go, let's make now this. Is going to create this flow, all right, using generator, the syntactical way of creating a syntactic form to describe a state machine. In other words, define this different step that we want to do, a series of flow from one state to another, to another, to another, which is, in pseudocode, we say, hey, we want to fetch data from here. Say, hey, I'm going to fetch data from here, okay? And once that data is there, I want to console log that, right? So this is pseudocode. So to create this, there's a lot of steps that we need to do. And using generators, you say, hey, create flow, right? This is the create flow. This is how you define here a generator, like that. We're not going to receive anything from this function. The subtle stuff with generators is that now they run stuff. So unlike functions, normal functions where they run to completion, now generators allow us to stop the executions and then pass control. So at some point in the future, resume that execution. Pretty much like when you go out or you navigate to let's say Netflix, right? You want to watch a Game of Thrones, and you hit pause, you freeze everything there, you make some popcorn, that kind of stuff, and once you're done, you come back, resume, and then you can look at your video. So this is the same analogy of the generators. So the way of how we can pause and resume is by using the GIL as a way to say, hey, pause this execution, freeze everything, like, hey, pause this execution and freeze everything, but first evaluate this statement and then pass control to them, which is, hey, I want to now fetch this data here, so fetch this data here, blah, 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 right? once that data is done, when we resume the execution of this data, because Jill is saying, hey, I want you to now is run this, right? I want you to now run this. Fetch me that data. So by the time that now is done, we're gonna get the value, we're gonna resume the execution, and then assign that data to this, so we can now console that log. So bear with me of how we're gonna do this. So because we are creating our flow, which is what we really care about, that this sequential blocking way of defining the set of instructions to the language, right? But here we need to define the pipeline or the plumbing behind the scenes, which is once we create our flow, which it returns us an iterator, in this case, how we can now stepping through this or how can we get in and get out of this function here, and also act as a message passaging. So we say, hey, I want to hold the iterator here, like so. Create flow, right? Pretty simple. So when we call this iterator, we say, hey, I want to get into this flow control and these generators, and then I want to now execute that line of code until you find a yield keyword and give it to me. So the way of how you can say give it to me that value is by using this. This is a particular protocol that they implement the iterators as a way to now consume this series of data, or in this case, this series of steps, right? So the value that we get here is now the promise, because actually it yields that. We return that promise. So by the time it returns the promise, we want is to store that promise here, which is future value, future data, something like this, right? And now you say, all right, so let me actually is, by the time that now I get that data thanks to the promise, which is eliminate time as a concerning factor, by the time that that data is there, then I want to subscribe to this and now pass control or resume control to the flow. In other words, you say, hey, once I get the data, I want to now pass control to this cooperative concurrency, which is something that is actually described here. So now it is at the application layer, so the application itself handle task scheduling. So by the time that this data is done, remember this is all of this is plumbing. So by the time that this data is done, then I want to now pass control or resume to that particular flow. Now, this is done by .next, and then you pass the value to that. So by the time that we run this, right, it's an expected token. Well, I'm not surprised for that. An expected token where? Oh, of course, at the beginning. That's right. So we want to fetch data from that. That's what we want to do, right? We want to fetch some data from that, and once that data is there, I want to console log that out. That's, as a user, as a developer, that's what we want. And we need to understand is now all the different pipeline, the mechanism to make that happen. All right, so once we get here, you do this, right? The promise pending, and then you get now your response. You can actually say, hey, okay, but I want to get now the data, not the response. So, no problem. You might say, hey, once I, this is now the response here, right? You can say it's like, hey, well, once that response, which is comes into a raw binary bit. So once you receive all of this string in a collection, in an array buffer of unsigned 8 bits, most likely, then I want you to transform into a readable format in this language. In other words, into a JavaScript object notation. So because this is something that you have to wait for that to be completed, right? So I want to now yield that again as a promise, and once that is done, I have now the value that I want and store that into a count. So I don't want you to modify or reassign that value. So we need to actually handle these specific use cases here, right? Which is, all right, by the time that this data is there, okay, we're not only going to pass value, but we're also going to now receive a value from this, which is this response as a promise. So we say, hey, this is now a value that we're going to receive, right? So we here is resume execution by passing the value on the generator. It evaluates that and say, hey, now this is the data that I'm receiving here, and I pass to the response. It continues to evaluate, but this time is this response.json. Since this is a promise, it returns that for us. This is how can we receive that into the value, all right? And because this is a promise, and luckily for us, that promise is also a way of defining is not only data flow, but also flow control. So we can is subscribe to that or change that on another promise. Just going to put this here as response, right? Which is more accurate. And then you say response, right? And once we actually, in other words, once this data, which is a promise of the JSON response to be resolved, right? Which is now passed to the micro task. And once the micro task is done, now the event loop is evaluating that and say, hey, is the call stack is empty? If it is, all right, now pass is whatever you have on the micro task and put it on the call stack to be evaluated. So in other words, is by the time that now this data is resolved, you get the value here. Now we can say, hey, let's go into coordinate again the execution of our program. In other words, the application schedule, or the application itself in this case, is handling task scheduling. So let's go into now resume the execution of this generator or this flow control, and then pass the data as it is. So now we will get is the proper object as it is. Completed false, IDA, user one, the lectus, I don't know if this is the one. Yeah, that's right, it is. So all of this, all of this is just to only describe that now in threads, in processes, the way of how those are run by the OS is using context switching, but because that is quite expensive, because it needs to hold the state of the process at that current point, and then now pass the previous and and then pass a different process to the CPU at that particular point to be evaluated, because this is expensive. There are now different mechanisms to help to solve that. So fiber is one of them, and the fiber is one of them, and the coroutines. Both of them rely on the cooperative concurrency. In other words, a task must be pass control before another takes in, before another can run. So in other words, is at the application level that is at the application levels that handles the task schedule. And this does not require some careful programming.
It is a responsibility of the application to make sure a long-running task is broken up by yielding periodically. This concludes our discussion of
So, yeah, basically. So, again, the idea of understanding and looking at that, right, is because this fiber that hold this additional information about the component 3, we can say is that anyway, resemblance. In coroutine. Fiber and coroutine mechanism for dealing context switching in, I think it is. Does fiber and React got any resemble with fiber and coroutines mechanism for dealing context switching in threads and processes? In context switching, exactly, with fiber and coroutines mechanism for dealing context switching in threads and processes by the OS. Because I really would like to know about that, right? So in any case, this is the idea here. This is the idea here. So why am I mentioning this? Because this particular mechanism, which is React, at the end of the day, is only take care of rendering your UI elements, and they have these different phases. So the trigger, the commit. So the trigger, the rendering, and the commit. It is on the commit when now, depending on when this happened, if this is on the initial rendering, of course, it called all of these elements using the append child. So it's going to call all of this to actually show them on the screen. But if this is during a re-rendering or during a component along the render tree, then you're gonna apply the minimally necessary change to the DOM to match the latest rendering outputs. In other words, is to now sync the virtual DOM with the real DOM. And the virtual DOM is this ideal, it's just a programming technique to have an ideal representation of the DOM in memory and then sync with the real DOM, right? So, again, all of this is because this is React, right? And since now we or the developers on React wants to bring the development of user interface also to the mobile, right? So now they create this React Native, which is a bridge. Right now they're not using a bridge anymore, but they're using some other components behind the scenes. But the idea pretty much is that they have now the UI threads, which is where React renders. And if you don't believe me, is here, by the way. You got it. Okay. Is the update well-defined event loop processing models like this. This is how actually before it works. The most important change to this proposal we'll introduce is the order of execution of use layout effects, use effect, and mounting the change in the host platform. What will be considered repaint in the browser terms. So at the moment, after every commit in React, this happens in parallel. Exactly. At the moment, after every commit in React, this happens in parallel. So React propagate ref, mount effects, execute use layout effect callbacks, and lifecycle methods like component did mount and component did update, and mount passive effect, which is synchronously or in a micro task depending on the priority of the current rendering in that order. And the React Native render schedule a task in the background thread to commit the new UI3 and compute its layout. When that is complete, the host platform is notified, which is the main thread, to mount the change in the main thread. So now, this is called as the async event update. But now it is resembling to the model, this resembles more of how the web works. So you have now the JavaScript threads, where now the UI rendering happens, right? All of this React commit and Fabric commit. So React commit is all of this change that happens to the DOM, and then the Fabric commit and layout. I'm assuming that they are now those changes that happened on the host platform. Okay, Fabric commit and layout. We can take a look now actually to do that. So Fabric or ask Claw here. Please don't temporarily default into consist response. I'm not surprised. So what is the difference between the React commit and Fabric commit in React Native. Fabric commit, new architecture introduced to improve performance, process update asynchronously on background threads, reduce main thread blocking, better handles complexity layout and animations, and enable features like concurrent rendering. And part of the new React Native architecture alongside the C++ core. The main advantage of the Fabric commit is better performance through parallel processing and reduced main thread load. Okay, so they are not. But what is Fabric? You know. So what is Fabric? Actually, it reply Phasma. Is a React Native new rendering system that uses CSS plus core instead of JavaScript bridge, enables concurrent rendering and better performance, and handles UI update asynchronously, provides better integration with host platforms, improve memory use and app startup time, support features like off-screen rendering and share elements transitions, is part of the React Native new architecture alongside turbo models and CodeGen. The key improvement is eliminated the JavaScript bridge bottleneck by allowing direct communication between JavaScript and native code. So Fabric is part of this. So let me see if they actually mentioned Fabric here. Fabric. The React Native renders Fabric is configured as not having support for micro tasks. So the reconcilier fallbacks to using schedule functions to schedule tasks with immediate priority. We will need to add a feature flag in the React to enable use to micro tasks in Fabric. The new React rendering Fabric provides an option to commit React tree in the background threads doing layout mount, etc. Asynchronous outside of the JavaScript threads. This option was provided to offset some of the performance regression that Fabric introduced due to the increased amount of work that is performed in JavaScript threads. Unfortunately, it is also the main reason why use layout does not have the correct semantics in React Native. As part of this proposal, that option and the background executor will be removed. Drawbacks, alternative, adoption strategy. How do we teach this? Especially with this. So this is Fabric. So how does Fabric work? The render phase, the mounting phase, and the layout phase. How? Where can I look? Okay. Fabric mechanism. React Native. With improved interoperability between host view and React views. Fabric is a React Native new rendering system, a conceptual evolution of the legacy render system. The core principles are to unify more rendering logic into C++, improving interoperability with host platforms, and to unlock new capability for React Native. But the point, the TLDR of this is to unify more render logic in C++. So development began in 2018, and in 2021, React Native in Facebook app is backed by the new render. The documentation provides an overview of the new render and its concept. It avoids platform specific and doesn't contain any code snippet or pointer. This documentation covers key concept, motivation, benefits, and overview. Okay, to talk about this. Fabric render. React Native execute the same React framework code as React for the web. React Native execute the same React framework code as React for the web. However, React Native renders to general platform view, host view, instead of the DOM node. Okay, when we talk about here rendering, is now instead of generating DOM nodes, it's going to generate now platform specific views, which can be considered web host view, which can be considered, but they are not. Rendering, exactly, web host view. Rendering to the host view is made possible by the Fabric render. Fabric lets React talk to each platform and manage its host view instance. Hey, I generate this and talk to each platform and manage its host view instance. The Fabric render exists in JavaScript and target interface made available by C++ code. That's quite interesting. Host view 3 and host view. 3 representation of the view in the host platform and Android iOS. Android that host view are instance of the Android view group and Android view text view. Exactly. So they now generate that. So the Fabric, unlike React, which is generating is now DOM elements, it generates now DOM platform specific views or rendering host views, which are building block of the host view 3. The size and location of each host view are based on layout metrics calculated with Yoga, and the style and the size and the location of each host view are based on the layout metric calculated with Yoga, and the style and the content of each host view are based on the information from React Shadow Tree. This is at least very important to understand that how now React Native work behind the scenes, because this will open up of what these different components are made of, what is the anatomy of this, be able to describe, and anytime you write a particular instructions or when you want to have access to the UI element, right, or some of the API that React Native exposed to you, so you can go with. Now it makes a lot of sense to actually understand the anatomy of React Native, which is made of the Fabric, where instead of using a bridge, is now have much more render logic into C++. So this Fabric, this rendering, is pretty much like React, but since React generates or renders DOM elements, React Native render is host view specific or host view 3. Interesting. And the way it calculates that, so the size and the location of each host view are based on the layout metric calculated with Yoga, which is a particular components here. And the style of the content of each host view are based on the information from the React Shadow Tree. The content is based from the React Shadow Tree. The position is based on the layout metric. Interesting. So the content is based on the React Shadow Tree. The position is determined of the layout metric calculated with Yoga. And then you have other components here. So you have JavaScript interface GSI, a language API to embed it, a JavaScript engine in a C++ application, Fabric uses to communicate between Fabric C++ core and React. Interesting. So they have now this component or interface, Java native interface, an API to write Java native methods used to communicate between Fabric C++ core and Android. React components, which is this JavaScript functions or classes concerned how to create React elements. React composing components, React components with render implementation that redoes to other React composite components, and React host components. So React host components or host components, okay, all right. React component with render implementation that reduce to other React composite components or React host that redoes to other React components. React host components or host components, React components whose view implementation is provided by a host, view and text on the web. React DOM host components will be components like p and div. React components or host components whose view implementation is provided by the host view on the web is React DOM host components will be the components like p and d. React element 3 and React element. A React element 3 is created by React in JavaScript, and after all, it create now is this, or it calls the append child or the create elements on the web. A React element is a plain JavaScript object that describes what should appear on the screen. It includes prop, style, and children's, part of the create elements methods from the DOM API. All right, so React element only exists in JavaScript and can represent instantiation of either React composite components or React host components. Read more about the component element in this blog. And React Native framework. React Native allows developers to use the React programming paradigm of how you can compose your components to ship applications to native targets. The React Native team is focused on creating core APIs and functionalities that fits the most general use case when developing native apps. Shipping native apps to production usually requires a set of tools and libraries. Shipping native apps to production, like this. Shipping native apps to productions usually require a set of tools and libraries that are not provided by React Native, but are still crucial to ship an app to production. Example of such tools supporting for publishing applications or to dedicate store or supporting for routing and navigation mechanism. So when those tools and libraries are collected to form a cohesive framework built on top of React Native, we define a React Native framework. So an example of open source React Native framework is Expo. However, because at the end of the day, React Native is just to render UI elements on those mobile hosts that they use now is the host component views, all right, or exactly the host components. React team focuses on creating core API and functionality that fit most of the general use case when developing native apps. And that's all. We are focusing is on the core APIs and functionality that you can use in your React Native apps, right? Whether it's on the UI elements and some of those other API. But because you also require is to ship to production, okay? because you also need to publish applications to a dedicated store and provide routing and native mechanism. Now, this is what React Native frameworks provide. And React Native frameworks like Expo is an open source. So this is quite interesting. So React Native only provides is the basic common, so it provides core API and functionality to cover most of the use cases. That is UI elements, right? UI interactions, connectivity. Period, bro. That's okay. Makes a lot of sense. And now React Native frameworks that recognize that when you're developing your mobile apps, you also need other parts that are crucial to the development and to ship to production, which is publish your app to the relevant store, or have some routing and navigation mechanism. Having some routing and navigation mechanism. Interesting. Routing and navigation mechanism makes a lot of sense in JavaScript runtimes and all that kind of stuff. Cogent. And Cogent. Okay, that makes a lot of sense. That makes a lot of sense. So that'll be all for this video. Take care. Bye bye.